Hello, ChipGT here, and in this video we are going to talk finally about the spooky interface that I've just designed. We're going to 3D print it, we're going to cut down the flange edges. There's a lot going on in this video, so let's go ahead and get right to it. Okay, so like I said, this is the flange, or not really a flange, it's a 3D printed part. It will be a 3D printed part, I should say. And some of the key features to this, I just wanted to point these out before we get too much further into it. So I decided I'm not going to use the spacers. The spacers, I mean, they were a good idea, but I don't think I'm going to be able to use them. I think it's better to have a 3D printed part that's kind of flush against the metal. So I'm not going to use those spacers. So this design takes that into consideration, and this gap down here at the bottom, this highlighted gap, that's for the hinge. So I'll go ahead and I'll turn on the right display hinge. So there it is. I gave it a tolerance of 1 millimeter, and it won't be able to make this thing slide up and down. So this is going to be all the way in the upright position, and we're going to make sure that this lines up just right. And then this can slide a little bit, wiggle left and right, just a little bit. All right. So that gives us a little bit of some tolerance there. This part itself is actually broken down into 3 components. Let me explain those real quick. So you have the main body here, and then you have a upper clip and a lower clip that'll help hold everything together. But first, I'm just going to go component by component and show you some of these features that I designed in. So next is the gap. So that's a 1 millimeter gap there for the hinge. This gap right here that's highlighted, that's a 2 millimeter gap, and that is for the glass, because it is 2 millimeters. Give me 1 second here. There you go, monitor plastics. So that's how that kind of fits in, and I'll go to a top view so you can see it a little bit better. So this cuts in and it holds the plastics in place, and then you see how there's a little bit of a lip here. This actually matches the contour of the bracket that we made in the last episode. Okay, so let me go ahead and turn the bracket on now, the mount. There it is. And I went ahead and I cut down. I knew where we needed to cut, so I went ahead and I cut it down, and the lip doesn't protrude through. And then in the side of the bracket, I made room for holes so that we could, if we wanted to, we could try screwing it in. And there's another hole right there so it can screw into the bracket. But the primary thing that's going to be holding this down is, and I'll just go to the top-down view again real quick. It's kind of hard to see because I have it kind of come over a little bit, but you can see it better on this front piece. So right where we cut the flange, we're cutting the flange right where the bend starts. All right. So the primary piece that's going to be holding this in place and holding it to the glass is going to be this 3D printed part that we make. There's a tolerance of a 0.5 millimeter here, which will be perfect for what we're trying to do. This actually has a bend to it, just like this has a little bit of an S bend to it. And then on top of that, for added support, I made this little cradle system here. It'll screw in with 1 screw, and then this flange here will butt up against the speaker, and I'll show you that here in just a second. So, but first, let's go ahead and bring in the front panel. There it is. So you can see kind of where the screws are. So that's the stud. This gives us a little bit of slide wiggle room, but keep in mind the bracket down here does not have that much wiggle room. It's only like 1 millimeter on each side. So you get 2 millimeters of wiggle room. The intent is that this locks in and holds it firmly in place. All right. Now go to the hardware here. So for this hardware combo, we have 1 washer in between the plastic, and then the standoff will screw down onto the stud. And then that leaves us with about 4.5 millimeters on the inside of the standoff. And we're going to use another washer here. And what this does is it creates a nice like 1 millimeter gap here. So this gap right here, this is for our foam, that foam that I got. We're going to use that gap there for foam to kind of hide the speaker a little bit. And then we're going to have the right speaker plate. Let me pull that up real quick. There it is. So you can see how this kind of goes together now. And then there will be a screw that comes in here. We might need a couple washers, or you know what? This might be a good place for us to put the those spacers that I purchased. We could use those spacers for like a 2mm spacer gap if we need it for the screw that's going to go down in there and hold that. And then what will happen is that this piece and the lower piece, they're going to butt up right flush against the side of the speaker plate here. So it'll come flush to that, and then I'll screw it in. I made a little bit of a gap here. I know it's way bigger than what it needs to be. And then we'll have one screw that holds all that in, just for added support when it's in the laid back position. All right. So this is the plan that I made to hold this in place. Before I model the other side though, I think we need to do a test print. We need to print out these 3 components, and we need to see how well they work and how they fit and how it aligns. And the biggest concern that I have is with the hinge down here. So if I turn off the display panel, we don't really have a whole lot of wiggle room here. Now I can come back in here and I can probably cut out a little more if I want to, but I want to just do a test fit. This test fit is, there's a lot that we're going to be testing, and I'm sure we're not going to get it right the first time. So first, we got to make sure these holes line up. We got to make sure these holes line up. We've got to make sure the upper holes line up here. We need to see how this is going to fit together and see how this piece fits together. So this is a lot of material to print that we may not know is exactly where it needs to be. I've put in a little bit of tolerances, and then we're actually going to 3D print this thing. The reason why I created these 2 pieces as a separate part is that this is going to print on the down surface and it's going to print up, because we have 3 different levels. You can't really see it, but the inside of the flange here, that is a 3mm gap. And then there's a 2mm gap for the glass here, and then there is a 1mm gap here. So there's like 3 different layers. This needs to be the top when we go to print. And then the channel on the inside, you guys can see we have this nice channel to run some RGB lights around the inside and have them trigger with DOF links. I think that's going to be awesome. There's enough of a gap here where we can just run the wires for that through this gap. 1mm is more than enough. There's plenty of room to, take it out the bottom and have it connect over for a daisy chain. So I think that this is a good prototype for us to try out. So let's go ahead. I'm going to put this on the print bed, and we're going to, let's see about printing it real quick. So, all right, so I'm here. I got this selected, STL. We're using Cura. Okay. It's loading up Cura. Okay, so gotta make some modifications. We can't print it like this, but we will rotate it and see if we can't get it to lay flat. And we're gonna rotate it this way. There we go. That is a very close, tight fit. So let's go ahead and slice it. It's going to take about 6 hours. I'm going to save it real quick to my desktop. And we're just going to call this S Spooky to Stern Interface. Save. All right, now. Okay, we'll connect to the printer. And get rid of that guy. Load in our file. And I'm printing with PETG, so we want 235 and 70 on the build plate. It's going to get up to temperature. And I'm going to cut it here, and when it gets up to temperature, we'll bring it back. Okay, it's loaded. Let's go ahead and print it. Okay, so this is what was just what you just saw get printed in that time-lapse video. And originally I had this come down a little bit and over, and it was a little bit thicker. I had to cut it off in order to make it fit into the stern frame, so that was a fix that we needed to do. And just as I expected, this gap that we made for the bracket that didn't give us enough wiggle room left and right didn't give us enough wiggle room. And then this piece right here broke off, and the reason why it broke is because these holes are just a little bit too small, and there needed to be some more tolerance between the top and the bottom because it caused this middle section to bend and break. And then also I've discovered afterwards that this top hole here is off. It needed to be 11 millimeters down instead of 16, so these holes were completely off. So this will go to the recycling bin. This is version 2, so it's got a nice clean bottom edge. You can see that the holes are 1 millimeter bigger, and you can see that the gap there is also bigger so that we have more wiggle room. And what I found out about this piece is that while I was able to push this up and get it aligned correctly, it's off from the face by about 0.5 millimeter. And I could either sand this down or file it down, but since I plan on providing this file to you guys for free on Thingiverse, I figured let's just go ahead, we'll fix it, we'll test it, make sure it's good to go, and version 3 is on the printer right now.
All right, let's go ahead and get our other 2 components loaded into Octopi. So this is the top component, and we will 3D print that. And we're using Cura as our slicer. And there it is. Let's make sure that we don't have any overhang. So I'm going to rotate this down. That way I don't have to print so much support material. So we'll just click on the part and rotate it. There we go. Make sure it's laying flat. Yep, that looks good. See how there's a little bit of a lip there? I just wanted to make sure, like, the only place that we should have any kind of support material is right there, that little bit right there. And I think that this part will turn out just fine. So let's go ahead and slice it. And we'll do a quick preview to see how the support material. So it's not even going to give us any support material because this rounded edge will support it enough. So, oops, sorry. Yeah, this rounded edge will do just fine. So I don't think, like, this is a 0 support material required for this print. So I'm going to give it a name of just upper clip, and then we're going to save it, and we'll just save it right to the desktop. And then I'm going to close down Cura, and we'll come down and we'll do the lower clip. Same thing. 3D print, put it in an STL file into Cura, and there's the lower clip. And actually that's not a bad way to do it either, but again, we're going to rotate it. I just want to make sure that we have as little support material as needed. Make sure it's flat to the surface. And that looks good. We'll rename it to lower clip and hit slice. All these settings that are over here, those are my settings that I use when I'm using PETG. So this is a 20-minute print, which isn't too bad. I'm having it print at a slower speed, and we'll save it to desktop. Now you can close down Cura. I'm going to minimize that, and I'll bring over Octoprint. So Octoprint is a great tool if you want to use 3D printing wirelessly from your desktop. And then I'm just going to copy over those 2 files, and I already went ahead and got it up to temperature. So we'll make sure that my camera is on and it's working. I'm going to do a nice time lapse for you guys. So we will go ahead and we will make sure that, yep, their filament looks good in the printer. All right, it is ready to go. So let's go ahead. We'll print the upper clip first. So load and print. All right, and it's going to start going here any second. At this point, while we wait for these components to print, let's go ahead and start cutting down the edge or flange of the spooky frame. But first we got to deframe it. So let's deframe it and then we'll cut that down while these are printing. All
right, so now I'm gonna go ahead and I'm gonna deframe the screen from this metal bracket. We want to be very careful on this ribbon because I don't want to have to replace this. And then there's 4 screws that hold it down to a 3D printed mount that came with this. And we're going to do the buttons as well. Take all of that to its hardware. This one. And we'll go ahead and we'll deframe this or take this off the frame as well. This is that 3D printed part that holds the PCB and mounts it to these standoffs. So it was really nice that this was included with the stern screen. If you choose to get that, all you get is a screen. You don't get the back plate, you don't get the PCB, you get just the screen for $200. Next, there are 4 screws, 2 here and 2 here on the side for this frame, and this is a jeweler's tool. I think it's an OT1 screw. So if you have an OT1 jeweler's kit or a jeweler's Phillips head, that's what seemed to fit best for me. I don't want to lose any of these teeny tiny screws, so I'll be right back. I'm going to go grab a little baggie to put them all in.
Okay, I'm just using a standard Dremel tool kit here that you can get at any of your big box stores. Make sure that when you do this that you have some extra cutting wheels because this is hardened steel, and as you can see from this time-lapse video, I go through a few wheels to cut this all down. After the first side is cut, I switched over to the second side and started cutting it down, and I cut it down very close to the flange. Like, it is very, very close. And once that was done, I used the grinding stone that came in the kit, and I grinded down the metal so that there were no metal shavings or metal splinters that I could get, and kind of rounded down the edges to make them nice and smooth. Once the flanges were completely ripped down and cut the way I liked it, I ended up taking it back inside, and I used water from the sink and a paper towel, and I tried to get up all the metal shavings off of this because I didn't want there to be any kind of metal that could possibly short out a circuit. So I really cleaned it down and just got it so that there were no metal flakes, and then I used dry paper towel to wipe it all up again, and then I let it air dry for about 30 minutes. After that, I put the monitor back into the frame, bolted the side bolts on the side, put the 3D printed component back on top, and bolted the PCB board and the button control back down, and plugged in the LVDT ribbon into the back of the monitor, and we were ready for a test fit.
All right, look at that. Version 3 is a nice tight fit here on the upper lip, on the side here, on the back lip down here. The gap right here, it ended up being perfect. The gap up here is perfect. The side edge here is right along the honeycomb, and on this side here I left it a little bit wider because I wanted the edge to turn and be the same on all 4 edges, and that just worked out perfect. I ended up putting 2 washers in here because the inside there, you can see where it's a little garbled up, it's a little goofy looking here. Get a better angle. So it's a little screwed up, and that's just part of the printing process. So 2 washers on this ended up giving me the gap that I needed for these spacers. The spacers ended up you know, holding it down in place really well. And I was curious as to whether or not the bracket would work with on the other side, and guess what, guys? Check this out. Boom, I already went ahead and printed the other side, and it's the exact same. It ended up coming out so freaking good. And there's still enough spacing in between here. There's still, like, it's right on that honeycomb seal. So version 3 works like a champ. I'm gonna give you guys the hardware list here. So we have a bag of washers, some machine screws, and then the standoffs. And they ended up working out really well. And you know, with those screws that are in the side, this gap that's right here that goes in the side there. I'll give you a different angle. You see this hole here where that gap is? I'm not even screwing anything through there. This is a nice tight friction fit. The screw that's in there is actually holding this to the plastic frame. And it ended up, like, I was really concerned about the weight on this and everything. But check this out, right? I'm gonna hold this here, I'm gonna flip it up. It is not falling out, guys. It's not even wiggling. It is in there rock solid. Okay, that friction fit on those 4 screws ended up working out perfectly. Now, if you are still interested in having another piece, like I have these extra pieces here, if you're still interested in doing my original plan and having this kind of give you some extra support, you can totally do that, and it will work. Okay? I just think that I don't need to. I think that this is in there so good, it's not even needed. And then on the speaker plate, because of the screws that I got, they're a little bit longer. So 2 washers here, and the spacer is 2 millimeters. So if you did 4 washers, you could very easily screw this down. Oops. You could very easily screw this down right there and butt it up nice and flush to that. And you could even put, you know, there's enough of a gap there, you could put some double-sided adhesive tape on there and just have it hold it in place, which you may need to do for the bottom because the holes are a little bit closer to this metal lip. But if you were to use these screws here, you could use that. You could, you know, hot glue it, you could epoxy it, whatever you wanted to do with this flange, because this flange is now useless. This flange is meant for the stern. We're not even using it. It actually sits higher than our monitor now. You see that? So that flange can be used as a mount point for just about anything that you wanted. So you could use this in a couple of different ways, however you see fit. And then, you know, either 4 washers and the screws will go right into here. I also recommend putting a washer on the other side. So put a washer in between the metal plate and the brass fitting, and then 4 washers and a screw. And these aren't going to go anywhere. Like if I here, I'm going to pause real quick. I'll put it on and show you. Okay, so we're back. 1 washer on the other side of the plate, 4 washers on the top, or 1 spacer and 2 washers. The spacer is 2 millimeters and each washer is 1 millimeter. And then the screw that I have in the package. And I've given you, like, the way that I've printed this, you have a little bit of wiggle room. You have some slide here. So if you want your speaker hole to be offset a little bit, or if you want it nice and centered, you can. This piece that I 3D printed will slide with it. It's the same gap. So you can see the hole there. Take my hand out of the light. So it'll slide all the way over with the speaker, the same distance it slides. And then you just figure out, okay, I want it here. And then you just tighten it down. And it doesn't take much. You just got to make it good and tight. Not super tight, just good and tight. There and there. And then also, if you slide it all the way over, it's actually hanging over the top of the monitor and acts as an extra lock, just in case. And then you just take a 3mm screw, any 3mm screw, and just screw it down in there. They are not threaded, so you will have to tap these when you screw them in. which is not a big deal. You just got to make sure you get the right screws. In the description, I'll actually label a screw that I recommend for this. I just have to go to the store and grab it. But again, this is rock solid. It is not gonna move. We don't have to worry about it. And just to demonstrate that to you, I will once again put it up in an upright position. So holding the hinge here, it's going up, and it's holding. See that looks so good. Okay, down in the description, I have provided you guys a link to my Thingiverse page where you can find the files that you need to print out these spacers so that you can have a Stern to Spooky monitor adapter. I will have all the smaller pieces if you want them, if you don't want them. It's going to be a total of 6 components on here. I am not going to give you this. You can just use the washers. It's not a big deal, and they're cheap. All right. So I will give you all the pieces that you need for this. I will include the files that you need to print it and the dimensions that you need for your print bed. I had to go in and modify my print bed because the Ender 3 recommends a 220 by 220 by 250, so I just modified my print bed volume to 235. You're going to need 235 to print this, okay? So set it to 235. Make sure your plate, your heating plate, is good and centered on the bed, and then you are going to have like a 2 millimeter gap on each side of the long sides of the printer when you go to print this. So make sure you have your printer volume set to 235, 250 if you're using an Ender 3. If you're using something a little bit bigger, you're not going to have to worry about that. But these parts ended up turning out perfect. I'm really happy with how they turned out. And then for this, now we're gonna the next episode, we're going to put lights on the inside of this lip. So we're going to get some RGB lighting in here. We're going to solder it up and get it ready to go. We'll put the speaker plates down, and then we're probably going to have to 3D print a custom speaker adapter here. So these screws holes, these pins, are actually really, really long for a reason. The speakers that we have will actually protrude through this hole. So we need to make a 3D printed standoff. So we're going to have a standoff, and we'll put the speaker on the standoff. If you found this video helpful and you really enjoyed it, please give me a like, please subscribe, ring the bell so that you know when the next video is coming out, and don't forget to hit your Magna save. I'll see you in the next one. Thanks for watching.